This session is abuse of CPE devices and recommended fixes, and we're going to hear from Dr. Paul Vixie, Chris Hallenbeck, and Jonathan Spring.
Go ahead. Yeah, thanks. Hey, stop leaving. So we're going to talk, I think that everyone has probably heard something about this, but we're going to go over in a little bit more detail and provide some good fixes. Now that you've all memorized that, I will let Chris introduce everything.
Yeah. You didn't want to let them read that for a little longer?
Good? Okay.
Lawyers. All right, so we've all known there's a problem with devices out there that are acting and being abused, but how big of a problem is it? Which devices is it? Anecdotally, we've known that for a while. So US CERT helped to fund through Carnegie Mellon a study to measure this and figure out really how big of a problem do we have and where does that problem lie. And then, of course, what we hope to get to is discussion about what do we need to do to start to address the problem at the whole.
So first, I'm sure you all know all of the acronyms because there aren't too many TLAs in security, so we'll be fine. What is customer premise equipment? Well, it's anything the customer has on their premises that the telco or the service provider does not own. We're going to talk mostly about home routers because that was an easy and good thing for us to measure. Any sort of public branch exchange, phones technically are CPE. If you Flickr search for an open source picture of a wireless router, apparently you only get rabbit ones. I don't know why that is. We're going to talk mostly about home routers. I think that once all the PBXs are software and you're running VoIP, they will really obviously have all the same problems. But Paul, tell us about what some of those problems are, please.
So the home router, the home router is fronting you to the internet. Everything you're doing, unless you have a mobile phone connected to a mobile network, everything is going through a small plastic box made by somebody whose real expertise lays elsewhere. So it is it's responsible for all kinds of things like translating your addresses, and I'll get to that in a moment. But most importantly, it can decide to proxy things that you might not have known were being proxied. So a lot of these devices, for example, will look into your packet and say, oh, you're trying to reach a DNS server to make a recursive query. I can do that for you, and I will just have logic built into myself that has a caching DNS recursive server, or perhaps you're trying to reach one that is not your ISP's, so I can't do the logic for you, but I can certainly redirect this packet where it should be going instead of to this strange Google DNS creature that you'd like to talk to. What that means is that anybody who can take over that box, and there are a lot of ways to do that, can also take over your DNS. And DNS, as you know, is the map of the internet, which is a territory. So if you can take over somebody's DNS, you can redirect anything else they do, just about. High-profile version of this story was told through Operation Ghost Click, where a bunch of Estonians and a couple of Russians took over DNS for hundreds of thousands of people and redirected it to servers of their choosing. And this was done through hacking into the CPE. So that's the size of the attack surface.
And then, of course, the other side of this is the ability to attack others through these vulnerable devices. We've seen a number of cases of this. You can look at the Spam House DDoS event, which was really kind of the high watermark for this kind of an attack. It's ridiculously simple to do. You've got a large number of systems out there to do it. And then you have things like DNSSEC that add to the fun. So US CERT had published out an advisory after a series of attacks. What it motivated us to do it? Well, the .gov domain DNSSEC, and it's signed. So it provides a very nice, sizable amplification for these these kinds of abuses. But the problem is not just that there's a lot that you can do to amplify, it's the reflection piece of it. It makes it ridiculously hard to track down really who's doing it. If you look at if you're the amplifying server, you just see the queries coming from these open resolvers. You never see the attacker doing the initial query. And of course, if you're in the middle and you're helping to be the amplifier, you look like you're the attacker to the ultimate victim in some cases. So it's a big problem, and it's only going to get bigger if we don't do something about it.
So, of course, we can't just scan the internet for all of the CPE and ask them how vulnerable they are. The Internet Census stuff tried to do that, but I don't think that really would have actually helped us measure it. What we can measure is open resolvers. The Open Resolver project measures that. There has been a small drop, which seems to be due to public outreach, but the small drop takes us down to 21.5 million instead of 25 million over the course of a year or so. And that's not really fast enough to really, if we keep going at that rate, this is going to be a problem until I'm dead, so that doesn't really help. But there are plenty of them, but where exactly are they?
So, if you have an open resolver in your house, it could be in the box, could be in that small plastic box I told you about, but it could also be a UPnP registered service running on any of your other PCs, laptops, etc. So to the extent that it matters to our study and it matters to how we remediate the problem, that we understand the exact size and shape of the threat, we're doing that at the moment using sort of link speed estimates to help us understand what kind of a link you have, and then use that in turn to categorize you as a threat. I mean, you're all threats, don't get me wrong, but some of you are worse than others.
So this is a two-step measurement. We got the IP location and connection speed data from Newstar, and I just mapped it to the /0 using some SILP tools that we have to make a PMAP and map the IP set and do some stats. So over the course of about a year, you see the unknown speed and the unassigned is going down as some of the internet gets assigned. There are more leased lines, T1, T2, T3, than there are DSL, but DSL and T whatever are also growing. Dial-up is the only thing that's really shrinking. How does this then compare? So this is my baseline. This is what if you looked at a random host on the internet, random IP address, this is what you would expect to find. However, if you tag all of those 21 million open resolvers, you get a very different picture. Almost half of them are on DSL, and most of the rest of them are on some unknown speed, which my guess is that actually means that that's a home connection somewhere that Newstar doesn't care to advertise to, but I don't actually know. The TX ones are way down at the bottom. There's as many cable ones as there are T1, T2, T3, which means that very few of the open resolvers are on corporate networks or on leased lines. Most of them are either a CPE or they're behind a CPE and that home router doesn't have the right firewall configured to block these DNS requests in.
So as Jonathan mentioned, a very large chunk of this happens to be just DSL by itself. So now you're left with a problem. How do you scale to address it? Are you going to go door to door, knocking on doors and saying, please update your device? What do you do to solve this problem? It's not really going to be solvable simply by going door to door. So we have to look at some other strategies for how we begin to address this.
So Dan Gear mentioned in his keynote yesterday that he does not think that we ought to be shipping devices, either small plastic boxes to your home or SCADA controllers for water pumps in power plants, whatever it is, does not think we ought to be shipping these devices that are both unupgradable and long-lived, because statistically speaking, and I don't think anybody here is prepared to dispute this, all software has bugs, and the longer you're running it, the closer you are to unity and certainty that those bugs are known to bad people who will then use them. So his proposal that we put an expiration date on these devices seems a little crazy at first, but that may actually be the cheapest and least crazy way to solve it. But the alternative is these device makers need to give us an update path, right? My phone and my PC get updates many times per month from their manufacturers as bugs are found. These devices, we've got tens or millions, perhaps hundreds of millions of these devices that are, as I mentioned earlier, your front end to the internet. They are extremely important, and yet most of them are not updatable. Even those of you who would like to replace the operating system with some flavor of Linux are starting to discover that the box you have does not have enough flash to run any modern software. So this really is, this in my opinion is a problem hiding in plain sight, and a lot of the other problems that we deal with as security professionals are built on top of foundations like this one.
So, obviously one option is make them expire. Not going to be a popular option with the environmental crowd for obvious reasons. That's a pretty high impact. So can we get these devices into a continuous upgrade? We're almost there now with the modern operating system on typical PCs with Windows. People just let them do their updates. A lot of the apps do their updates. Why not these devices as well? That means actually the device manufacturers have to have a requirement to do that. So if it's from an ISP needs to have that as a requirement to do that. There has to be some kind of a market push. But right now it's a manual process, assuming you can update the devices. And it's assuming that the owner of that device needs to know that they should be doing something with the device. It's something that sits in a closet, collects dust. As long as the lights are blinking and they can connect to the internet, or at least as long as they can connect to the internet, they're happy. Sometimes those things even die off on the little blinking lights. So they don't care. So why would they go and upgrade? We need something that just automatically does that for us.
So I mentioned that we're building a lot of important problems that keep us busy every day on foundations like these small, cheap, plastic, forgotten boxes. There are other elements to that foundation. The reason that DNS amplification works, or NTP amplification for that matter, works, is because there's a huge other end of the internet where you can send any packet you want, claiming to be from anyone you want. The relatively simple, straightforward operational practice of source address validation is not only not universal, it's not even considered universally considered to be a good. If you're running a hosting center or some kind of an ISP, business-grade ISP, this is one more line of config you have to have for every customer, which means it's one more thing you have to train your people to do, document, audit, add into the break-fix flowchart, and so forth. So it's a cost. Even though you're not having to buy more expensive equipment, it is still a cost. And if somebody's trying to justify that cost at the far end of the internet, they will likely go and say, well, this is the right thing to do. And their boss will say, well, will it save us money? No. Will it make us money? No. So who's it really going to save money or make money for? Oh, that would be our competitors. Okay, so you want to do this why again? All right, so we call it an asymmetric incentive, and almost nothing ever gets done when the incentives are misaligned exactly and diametrically in this way. So it's my belief that anybody who sends something into the internet or enables other people to do so should be held responsible. Some of you may be aware that I started the first anti-spam company, and it was on my premise, however naive at the time, that all communication ought to be by mutual consent. And we were getting a lot of non-consensual traffic, that is to say spam, back in the early 90s. Obviously, I did not solve the problem with that company. But I think the principle is still a valid one, and I'm not sure how to realign the incentives. It may be that this will take Underwriters Laboratory adding a checkbox to the small plastic box checklist, so that if you are able to send spoofed packets, then you can't be sold to an American consumer. That's not a law thing. That would be a private industry working for some common good. After all, if you have a toaster that's Underwriters Laboratory listed, that gives you some confidence that that toaster is not going to decide in the middle of some night to burn your house down. So there is some precedent for using private means to realign incentives, and we're pushing on that.
And that's the other part. So you talked about the asymmetric nature of it right now. There's a really not a good incentive for anyone to address this problem. For everyone involved, it's just easier to accept the status quo. It keeps costs down. So where do we go from here? Do we call for government regulation in this? Good luck with that. Now we're not talking about just the U.S. or just one or two other countries. We're talking a global problem. So you would need global regulation to handle that. So that's not necessarily the way that it's going to work. It may be a part of the fix for some of it. But do we treat this like a public health problem? Do we treat this like an environmental problem where government steps in to do some amount of it, whether it's regulation or whether it's facilitating, bringing the right people to the table to address it? Just the other day we were talking about something like an underwriter's thing, but maybe it's just a marketing differentiator where you set up a list of desirable features that make this device desirable from a security perspective, and that becomes some market differentiators for the manufacturers to say, hey, our devices are better for the overall ecosystem, and that's why you should buy our device over another. And that may be the only way we can go about doing that piece of it. So that takes care of the device itself. The reality is, though, these devices are going to be out there for a long time. So we've got twofold. One, we have to address the devices that are in place, get them upgraded where we can. Where we can't get them upgraded, we need network operators to take the appropriate steps to implement source address validation and other means to reduce the risk. We're never going to eliminate it. And then we change the supply chain pipeline so that devices that are coming to market in the future, hopefully to replace these existing ones, have the security features in place so that we overall reduce the threat over time. But this is a problem that's not going away soon.
Anyone have any questions, comments, magical suggestions that we missed that'll fix the problem tomorrow? Sure.
So do you have a sense of how we're going to get these things shifted through, whether ISPs might be a point of pressure, because typically either your cable company or ISP is the person supplying, at least initially, unless you're interested in that stuff, the device that will connect you to their service. So they have some kind of measure of responsibility to supply you with a device that will not screw their network and everybody else.
So I'll speak for Comcast, who is certainly well aware of all of the problems we've discussed. They're a major U.S. ISP access provider, so they are working with some of their fellow companies to sponsor some open source work in this area. After all, if we made a lot of old PCs useful by switching them from DOS to Linux, we could probably make a lot of these plastic boxes useful by switching from proprietary to open source as well. There is no movement afoot, given that the real debates are about network neutrality and SOPA and things like that. There's no movement afoot to require these things to be upgraded. In other words, to place a burden on the ISP at the government level to say, do this or else. But as you mentioned, it should drive your support costs down if these boxes were just a tiny bit smarter. So to the extent that they're really cheap, small plastic boxes, $50 US is the the street price at Fry's Electronics for a lot of this stuff. It ought to be possible for these companies to just recapitalize that edge of their network on a rolling basis. Take 3 years to do it, and pretty soon you've got a couple 10 million replacement devices out there. The cable companies, the DSL companies are aware of the problem, and they are asking the question you just asked. But there's no clear movement, there's no clear solution evolving yet.
This side of the room here, most of that. So this gentleman over here works for a service provider, and he said that they're looking at putting in filters at the modem level, you said, to filter this stuff out from the customers, because it is a big problem. The business level customers, if they have a real need to run a DNS server, you give them a different class of service and give them the configs, but default is to not.
That's actually one of the things, though, is a lot of entities will design for the edge case, for the small number of customers that may need that service to actually reach their device. So they end up defaulting to equipment and services that will address that. But the vast majority of their customers won't need that. So maybe it's a slightly different device for that small number of customers that need the extra feature set or whatever.
So if even 90% of the business customers don't know they're running a DNS server, then clearly most of the residential customers don't need one either. In the back? Do you want to?
Sure. So through the NVD, there's listings of all sorts of vulnerabilities in different devices. There's not a comprehensive one shop to say, show me for consumer premise devices, the ones that have various vulnerabilities. But one of the things that we've been discussing is maybe we create a list of desirable features from a security perspective, the ability to do upgrades, the ability to have automated upgrades, and then create a list of devices, not an endorsement or shaming or anything, just simply here's the desirable set of features, here are the known devices that have them and have kind of that consumer report style matrix of feature sets, and let people make those decisions, and maybe that becomes the way that people move that forward as well.
So the documentation isn't super clear about how they're doing it. But since my guess is that this is mostly to identify where someone is to advertise to them appropriately, is my understanding of how the service is sold. I'm guessing that speed unknown means that it's somewhere in China and they didn't bother. So I don't actually know. It means speed unknown because I don't have any idea. So OCX is optical leased line, whereas TX is Ethernet bundle loose line, but. Oh. This is the exhaustive list of all of the things that it's binned into. In the back. The question is, what percentage of the problem would implementing BCP38 solve?
If we had, and I don't think we could, so that we're in fantasy land here, but if we had universal source address validation, then there would be almost no point to creating a botnet. You'd still create a few of them because they can be used to send spam or whatever, but in terms of DDoS for hire, source address validation is the gate. If we had that, then we would not have DDoS for hire.
So the question is, what's the policy issue, or what's the road bump to get last mile ISPs from implementing SAV then?
We give these people great freedom to build their business competitively, and every time the government comes down with some compliance burden, these folks rightfully raise their hand and say, boy, that's going to thin my margins out even further. So I don't think we're going to solve this with policy. I think that it would be hard for a politician who voted to put his foot on the neck of the little guy to get reelected. So I think if we see this at all, we're going to see it come in the form of peering policies, where you won't be able to buy transit upstream of yourself or peer with other ISPs unless you have implemented source address validation towards your own customers.
But that also then means you've got to be able to measure which ones are commonly being abused to apply that. That means you have to have the cooperation to do the traceback to understand who's being abused routinely.
Now, unfortunately, source address validation can only be tested from within a network. We can't set it up at CMU where they reach out and probe everybody and give us some kind of a score sheet.